Well, this video is on absolute value inequalities, so this is going to sort of combine those two topics that we were just talking about, the absolute values and the inequalities. Alright, so we'll just start off with some examples here. Problem 2, we've got absolute value 4x plus 12 plus 2 less than or equal to 10. Okay, so just like those absolute value equations that we were doing in the previous assignment, the idea is we want to get this absolute value thing by itself. So that means we need to subtract 2 on both sides. And so now we get absolute value 4x plus 12 less than or equal to 8. Okay, so this is the point where we would want to split this into two pieces. Alright, now here's the thing. Remember that when we talked about inequalities, if you had negative 3x less than 12, when you divide on both sides by negative 3, that flips this around. Okay? So, when we split this absolute value up, and we put 4x plus 12 and the positive 8, and 4x plus 12 and the negative 8, this one will still be less than or equal to. Okay? This one, when we make this 8 negative, that flips this around because it's as if we had multiplied by negative 1, and there we go. Okay? That's the key to doing these absolute value inequalities. Get the absolute value by itself, and then when you split it into two pieces, when you make this negative, this sign will flip around. Okay, so now that we know that, let's get the x by itself. Divide on both sides by 4. So we get x less than or equal to negative 1. And over here, negative 20. And so we'll divide by 4. And then we get x greater than or equal to negative 5. So x less than or equal to negative 1, but greater than or equal to negative 5. We put this on the number line. And it'll look something like this. Okay? These less than problems will typically be an and statement, and we'll have this interval here. Let's see, do we have a greater than one coming up? Well, it'll take a while. Oh, they're grouped. Okay. So when we look at the greater than ones, you'll see that the greater than ones tend to be an or statement, and they go off in opposite directions. Okay, let's do a couple more of these less than ones, and then we'll take a look at the greater than. All right, problem 4. Let's see, absolute value, negative 5h minus 1 minus 6 less than 9. All right, similar process. Let's get the absolute value by itself. 15. Now we'll split it into two pieces. Negative 5h minus 1 less than 15. Negative 5h minus 1 greater than negative 15. Okay. Now, when I divide by this negative 5, this is going to flip around again. And again, you can leave it as negative 16 over 5 if you'd like to. Or you can call this, what is it, 3 1/5, negative 3.2. All right, over here, we're going to add 1, make that negative 14. And again, when we divide through with that negative 5, this thing will flip around. That'll be a positive what, 2.8, I believe. Again, you can call it 14 over 5 if you'd like, either way. So notice, less than 2.8, greater than negative 3.2. We put that on the number line. And you don't have to get too fancy with your number line. It is good to put a 0 in there so we know which side we're working with. And so there it is. All right. Let's see here. Okay, let's look at problem 8. We've got 4 times absolute value n plus 2 minus 3 less than or equal to 9. And again, like I said when we were doing these, the absolute value equations, this is as if you're doing something that was like 4x minus 3, okay? And you want to get this by itself, right? Because that's what we want to do. We want to get that n plus 2, absolute value n plus 2. We want to get that by itself. So we're going to add 3 on both sides. And then divide on both sides by 4. And now we've got our absolute value on its own. Okay? And that's the point where we want to split this in 2 pieces. N plus 2 less than or equal to 3. N plus 2 greater than or equal to negative 3. So, subtract 2 on both sides. And there it is. N less than or equal to 1, but greater than or equal to negative 5. And there it is. That's what it looks like on the number line. All right. Well, I think that those are some good examples. So let's take a look at the greater than problems. Make some space on the board. And we'll look at problem 10 to get us started here. Problem 10 says absolute value 2x minus 5 minus 1 greater than or equal to 10. Okay, so again, we want to get the absolute value by itself. So we're going to add 1 to both sides. And now we'll split it in 2 pieces. 2x minus 5 greater than or equal to 11. 2x minus 5 less than or equal to negative 11. Because this negative flips that sign around. All right. Now let's get the x by itself. And there we go. X greater than or equal to 8. And then over here, what do we get? Now again, if you're, kind of shaky with your positives and negatives, please use the calculator. Make sure that you get this value correct over here. Okay? All right, and now we'll divide on both sides by 2. X less than or equal to negative 3. Now notice, like I said, that this is going off in opposite directions. You've got 1 greater than or equal to 8. And then another one less than or equal to negative 3. Okay. What else? Well, let's look at 14. Got 5 times the absolute value of m plus 2 greater than 12. All right. So first thing, let's get this absolute value piece by itself. And then divide on both sides by 5. Okay, so there we go. And now, again, this is the point. Now that the absolute value is by itself, we want to split it into 2 pieces. And there's not going to be a whole lot of work in this one. right? We're just going to have m greater than 2 and then m less than negative 2. And so, on the number line, one's going to go off in this direction, and the other one goes off in that direction. Okay? And that's what these greater than problems generally end up looking like. They go off in opposite directions, and these are or statements. Or and or. Okay. Let's look at a couple more. Okay, let's do 16. That gives us 3 times absolute value x minus 2 minus 5 greater than or equal to 1. All right, so again, we want to get this absolute value piece by itself. So let's do that. And then divide on both sides by 3. Absolute value, x minus 2, greater than or equal to 2. So now we want to split it into 2 pieces. X minus 2 greater than or equal to 2, or x minus 2 less than or equal to negative 2. And in both cases, we'll add 2 to both sides, which will give us x greater than or equal to 4, or x less than or equal to 0. And on the number line, there's the 0, there's the 4. So this one goes off in this direction, and this one goes off in that direction. Okay, well, let's look at a couple more before we finish things up here. Problem 22 is kind of interesting. Let's see, we've got 5 minus 2 times u plus 4 greater than or equal to 1. All right. Couple things. First of all, remember your order of operations. This 2 is getting multiplied here. That means you can't do 5 minus 2 equals 3. It's just our order of operations prevents us from doing that. Okay? There are a variety of things that you can do here, and I'll do a couple of them. All right, we can subtract 5 on both sides. Don't lose this negative sign because that's a negative 2 times the absolute value of u plus 4 greater than or equal to negative 4. And then we would multiply or divide on both sides by negative 2. But if we do that, this thing's going to flip around and it's actually going to end up being a less than problem. Okay? What else could we do? Well, if you remember when I was talking about inequalities and why we flip this around when we divide by a negative, it's because it has the same effect as changing signs. So we can add 2 times absolute value u plus 4 to both sides. And this will be 5. This will be 1 plus 2 times absolute value u plus 4. And again, please don't try to add these numbers together. What we want to do is move that 1 over to the other side. And then we can divide on both sides by 2. And we get the same thing. U plus 4 less than or equal to 2. Okay, so however you go about it, it doesn't matter because you end up in the same place. All right? That's why I often compare math to taking a trip, because like if you're going into Portland, you can go out Highway 30. You know, maybe if you're going to Hillsborough or something, that part of Portland, you want to go down to Seaside, go over Highway 26, but you'll end up in the same place. Math is like that. Doesn't matter what route you take, so long as you don't take any wrong turns, you don't want the algebra cops coming to pull you over. All right, so we'll take this u plus 4 and we'll split it in two pieces. U plus 4 less than or equal to 2, or u plus 4, actually this will be and, u plus 4 greater than or equal to negative 2. And in both cases, subtract 4 on both sides. And we get u less than or equal to negative 2. And greater than or equal to negative 6. And remember, this was a less than problem, and so we end up with an interval like that. All right, let's see here. Okay, let's look at one more, and then we'll wrap things up. Okay, problem 24. We've got 4 times 3p plus 6 minus 2 less than 22. So again, we want to get this absolute value by itself. So I'll add 2 to both sides. That'll be 24. And then we'll divide on both sides by 4. And that'll be 6. Okay, so now we want to split this in two pieces. 3p plus 6 less than 6. And 3p plus 6 greater than negative 6. So, subtract 6 on both sides, and then divide by 3. And that'll give us p less than 0. Over here, subtract the 6 on both sides, and then divide by 3. And we get p greater than negative 4. And so now, if we want to put this on the number line, let's see, less than 0, but greater than negative 4. And double check, this is a less than problem. That means we want that interval. Okay. Well, I think that's a pretty good collection of examples. As always, if you have any questions, please let me know. We'll be starting those Zoom conferences during week 2. Let's see, for Math 95, that'll be Monday at 9:30. And anytime that you need to talk to me or communicate with me outside of that, you can email, call me on the phone, and I'm also having office hours by appointment. Okay? So if you want to come into campus and talk with me, then just give me a call or email, and we'll set up a time to work that out.